Section 2.4 in the textbook discusses reflections of functions. Reflection is a transformation in which the figure is reflected over a reflection line. Think mirrors. Okay. What we're doing is we're taking a mirror, and let's pretend that this protractor is a mirror, and we're reflecting. What would this function look like if it were mirrored in this mirror, this pretend mirror anyway? Well, it would be on this side and it would go this direction if the mirror is along the y-axis. So a reflection like this we call a reflection in the y-axis. This would be a reflection in the x-axis. We'll try them both. So if sometimes we take our reflection, our new function is the same as our old function with a negative in front of x. This means that any point we're calling xy becomes negative xy. This is a reflection in y-axis. Okay. How do we do it algebraically? Algebraically, we replace any x with negative x in the expression. If we have the graph and we want to do it, we take every x coordinate. So here we go. This point is 4, 2. Well, when we do the reflection, it becomes negative 4, 2. We get a negative in front of the x-coordinate. We could also reflect in the x-axis. So that means our mirror would be put right here, and that this function along the top gets mirrored and becomes this function down at the bottom. We say that any point xy becomes x negative y. This time the negative is on the y, before the negative was on the x. If we're talking about the function has a negative out front. You multiply the entire expression by negative 1. And so if we had a point, let's go with our same point, 4, 2. The original becomes still 4. But now we become negative 2. Negative 2, 4. So we can reflect in the y-axis, we can reflect in the x-axis, we can reflect in both. 2 ways of thinking about this, maybe even 3. We can think of this as first a reflection in the x-axis. So we take our original expression, we flip it over, and it would be down here. And then we take its new one and flip in the y-axis, and we get our new function. So it's a 2-step reflection. It could also be thought of as a rotation. Let me take this piece of clear plastic. Hopefully you can see that. Let me trace. Our function looks like that. If I take it and spin it so that the starting part stays the starting part, we get the same graph. So this is almost a rotation of 180 degrees. So this is a reflection in x followed by reflection in the y-axis, or rotate 180 degrees, halfway around. To do this, it's a combination of both of those. We put a negative in front of the f and a negative in front of the x, so a negative in front of the whole function and a negative in front of the variable. We replace x with negative x, and then we multiply the entire expression by negative 1. So our point 4, 2 becomes, first, if we're going to do this intermediate one, where first we're flipping in the x-axis, it would become 4, negative 2, and then finally negative 4, negative 2 for our final one. So reflections, mirror images. Our first example, given the function f of x equals square root x plus 2, write an expression to represent each of the following. Then sketch each graph and state the domain and range with each function. So let's try to remember, think back. The parent function is square root x. Typically we draw that as starting here if it's going to be a function, and we use the points 4, 2, and 9, 3, and 0, 0 as the ones that we think of. We've already got a transformation in this +2. That means everything would move up 2 spaces. So we've got one of our points as x equals 0, y equals 2. We've got one of our points as x equals 4, y equals 4. And our last point, our 9, is that x is 9 and y is 5. Alright, so this is our f of x in purple. If we're going to do a reflection, h of x is a reflection in the y-axis. Y-axis like this. So if it's reflected in the y-axis, we expect it to be over here. From our note in the beginning, a reflection in the y-axis means we put a negative sign in front of any x. Not a negative sign in front of the entire expression, one negative sign in front of every x. So that means that our new f of x, or h of x, is going to equal, it's going to be square root of negative x plus 2. And it means that we take every point that we've identified and the x becomes negative x. So instead of having 0, 2, we put a negative in front of the 0 and it stays right there. Not really a move. Over here, instead of +4, +4, we're going to have -4, +4. Here, instead of +9, -5, we're going to have -9, +5. So what does our function look like? It looks like that. So that is A. So to reflect in the x-axis, when we take a look over here, if we're looking at the equation, a reflection in the x-axis means we put a negative in front of the entire equation. So that means r of x is going to equal negative, and I'm going to put it in a big bracket, square root x plus 2. So you could write that as square root x minus 2. Either way. Alright, so that also means that for a reflection in the x-axis, you're going to take each of the points, x, y, and it's going to become x negative y. So 0, 2 is going to become 0, negative 2. 4, 4 is going to become 4, negative 4, and I'm going to have to stretch it off the graph. 4, negative 4. And 9, 5 is going to become -9, 9, negative 5. It's the y coordinates that's changing, and that's something like there. Sorry, I made the graph wrong. Alright, so there is r of x. To go along with our h of x and f of x. Our final graph is going to be s of x. It's a reflection in the x-axis, and then, one in the y, and then already one in the x. So what I'm going to do for that is you put a negative out front and a negative in front of the negative. So what this becomes is s of x equals And so let's take a look. If we take this function, it becomes negative square root negative x minus 2. So we took this one, so there's already a negative in front of the entire function from r, and we put an extra negative right in front of the x. What does that mean in terms of the points? It means both of these points become negative. 0, 2 becomes 0, negative 2. Positive 4 becomes negative 4, negative 4, and again, my apologies. Negative 4, negative 4, oops. And my last one, 9, 5, is going to become negative 9, negative 5. There we go. For example 2, what we need to do is look at each graph and describe the reflection that transforms f of x, which is our dotted line, so this guy here is f of x, into just x, our solid line. Let's go ahead and change that. Let's call it g of x. F and g are the two favorite labels for functions. There we go, f of x and g of x. So, just looking at it, you might be able to see that yes, this is a reflection, and it's a reflection in the x-axis. If you're not sure, or if it gets more complicated, you can go ahead and try a few points and see what happens. This point has an x-coordinate, but it has no y-coordinate. Well, let's call this x equals negative 5, y equals 1, 2, 3, 4. And here, x equals negative 5, but y is negative 1, negative 2, negative 3, negative 4. Okay. So if we see our x-coordinate stayed the same, but our y-coordinate gained a negative side. So which of these cases did the y-coordinate gain a sign? Well, not there, not there, this one. So y-coordinate became negative, x-coordinate stayed the same. And this one, the x-coordinate's different. So it's a reflection in the x-axis. And so our original f of x, so we could write that g of x is equal to f of x. If it's a reflection in the x-axis, that means a negative out front. So g of x is the exact same thing as g of x is the exact same thing as f of x, except there's a negative out front, making a reflection in the x-axis. Our last example, we have our f of x over here, and our g of x down here. F of x and g of x. So a point on f of x might be something like 4, 1, and over here it becomes 1, 2, 3, 4, negative 4, down 1. So if you look, the signs have changed on both the y-coordinate and on the x-coordinate. The signs changed on both coordinates. It's a reflection in the x-axis and in the y-axis. In both x and y. To show that algebraically, it's a negative in front of the f and a negative in front of the x. So this means that our g of x, our new graph, is the same as our old graph, assuming you reflect in the y-axis and you reflect in the x-axis.